All right, welcome Geometry B folks. This video we're going to cover 30, 60, 90 triangles. If you want to do exercises on IXL, you can use the code E9S. That exercise, keep in mind, will have 45, 45, 90 triangles as well as the 30, 60, 90 triangles. But one thing about these 30, 60, 90 triangles, a lot of people might kind of memorize some formulas here. So you might use the formulas that the hypotenuse is the short leg doubled, short leg times 2, the long leg is the short leg times square root of 3, and that's okay, but you're going to have to memorize that. What I recommend memorizing instead is the guide triangle, which has the hypotenuse is 2, has a long leg of square root of 3 and a short leg of 1. We know the short leg is opposite the 30-degree angle and the long leg is opposite the 60-degree angle. If you put those into a table, if you put it in order of short, hypotenuse, long leg, you get the square root of 3. Okay. One other thing, just to make sure that you are aware of, some people might say, isn't the hypotenuse the longest side? And isn't square root of 3 bigger than 2? But keep in mind that the square root of 3 is approximately 1.7 if you were to punch that into the calculator. So the hypotenuse 2 is bigger than the long leg at square root of 3. So let's do some examples here. So this is an example I took from IXL. They give us this side length of 16 millimeters. That's what that is. And they want us to find this side length. They marked N. I thought, let's just go ahead and find the other unmarked side length as well. I marked that K. And let's identify these sides before we proceed. So we know that the hypotenuse is opposite the right angle. So that's 16 millimeters is the hypotenuse. We said the short leg is opposite from the 30-degree angle, so N represents the short leg. I'm just going to say short. And opposite the 60-degree angle is the long leg. So what I'm calling K here is the long leg. So I'm going to set this table up and I'm going to fill in the values. So we've got for the guide triangle, the short leg is 1, hypotenuse is 2, long leg is square root of 3, and I think that's easy to memorize, 1, 2, square root of 3. And then in our given triangle, we have the short leg is N, the hypotenuse is the 16 millimeters, and the long leg is what I'm calling K. So if you can get that, now it just becomes setting up these proportions, these equal fractions. So typically what I recommend is with the two variables, when you want to solve for one variable, ignore the column for the other variable. So let's say I'm solving for N. I can ignore the column with K. I mean, I'm not going to actually scribble it out, but I'm gonna cover that up there. So when I look at that here, I go, all right, so I see the proportion 1 over N equals 2 over 16. Just kind of jumps out at me when I ignore that column with K. And then I can cross multiply and divide. So 1 times 16 divided by 2. And that's going to come out to be 8. So if you want to put millimeters on that, I guess. But that's our length for N. When I do the value for K, I can ignore the column with N. So we'll switch the color here, but I can ignore this column while I do the value for the other leg or the other side, I guess. So the proportion, again, kind of just jumps out at me. I got 2 over 16 equals square root of 3 over K. Cross multiply and divide here. So we got 16 times the square root of 3, and we're dividing by 2. If you remember the trick here, and one of the reasons that I write this as fractions is because the numbers that are outside the square root, if we're multiplying or dividing, we can go ahead and perform that multiplication or division. So 16 divided by 2 is going to give us 8, but then we're still multiplying by square root of 3. The only other thing I would do here is just to double check that, the short leg should be the shortest side of the 3. The hypotenuse should be the longest side. So this long leg should be kind of the middle or the medium side. So you can grab a calculator if you want, and we can punch in 8 times the square root of 3. 8 times 3 square root there. And we get 13.856 whatever. And I go, yeah, that's in between the 8 for the short leg and the 16 for the hypotenuse. So it's a reasonable answer. We're looking for exact answers here. So we got N is 8 exactly, and K is 8 square root of 3. Let's try another one. All right, so here's another example from IXL. Again, we got the 30, 60, 90 degree angles. So first thing to do, identify those sides opposite the right angle. There's our hypotenuse. Don't know why it's doing this right now. Opposite the 30-degree angle is our short leg, and opposite the 60-degree angle is our long leg. And let's give that a name. Let's call that, I don't know, maybe I'll call that K again. And so let's fill these into the table. All right, there we go. So if I want to start with D, I can ignore the column that has K. Temporarily, I'll need that column when I solve for K, but again, I've got the proportion right here. I got 1 over 9 equals 2 over D. Cross multiply and divide. We got 9 times 2 divided by 1, and that's going to all come out to 18. This time we don't have any units. And then looking at, if we're solving for the other leg, even though IXL didn't ask us for it, we can ignore the column that has D. So we'll do that here in this color. So I could ignore this column. So this one may be a little more difficult, but I can still see we got 1 over 9, and then the other fraction square root of 3 over K. And if we cross multiply and divide there, I'll do it over here. 9 times square root of 3, and we're dividing by 1. So again, we can perform the division with numbers that are both outside. 9 divided by 1 is 9, so K equals 9 square root of 3. Again, the only other thing I would do is check to make sure this is reasonable. We think K is the long leg, so it should be kind of in the middle. It should be bigger than the short leg, but it should be bigger, it should be smaller than the hypotenuse. So if we grab that calculator and say, all right, 9 times the square root of 3 is 15.588 something. And I go, yeah, that is, the hypotenuse is 18, so we're smaller than the hypotenuse, but the short leg is 9, we're bigger than the short leg. So we have reasonable answers here. Okay, let's do another one. So another one from IXL. This one may be a little more scary looking because we have a square root already. But let's go ahead. I'm going to identify the sides and I'm going to fill in the table. So there we go. I've got my sides labeled. I've got it filled into the table. Again, the unmarked side, just in case we want to know it, I said let's call it K. That is the hypotenuse in this case. And all right, so maybe I start with W. I can ignore the column that has K. And here's my proportion. I got 1 over W equals the square root of 3 over 5 square root of 3. I'm still, even with these square roots, I'm still cross multiplying and dividing. So we've got 1 times 5 square root of 3, and then we're dividing by the square root of 3. So this one's a little more difficult, perhaps, but like the 1 times the 5, those are both outside the square root, so we can multiply those. That's going to give us 5. And then what happens with the square root of 3 divided by the square root of 3, if you remember this like from algebra, is it's just 1. It basically cancels. You could say it cancels to a positive 1, so it's like 5 times 1, but that's just 5. So W is just 5. That's our exact answer for W. Okay. If we do K, if we do the hypotenuse here, so maybe I ignore the column of W, and here I've got, I'll put it up here, we got 2 over K equals square root of 3 over 5 square root of 3. And so again, we can cross multiply. The 2 and the 5 square root of 3 are diagonal. Those get multiplied. And then we divide by the square root of 3. So we're going to have something very similar happening here. We can multiply the 2 times 5. That's going to be 10. And square root of 3 divided by square root of 3 is 1. If you want, you could say 10 times 1. Or you could just say 10. That's it. That's what we've got there. Last thing I'm going to do just to make sure is I'm going to say, all right, this long leg needs to be kind of the middle side. It needs to be bigger than the short leg, but smaller than the hypotenuse. So I'm hoping 5 square root of 3 comes out to be something between 5 and 10. 5 times square root of 3 is equal to 8.66 something. So I go, all right, so seems reasonable. Short leg is 5, long leg is 8.6 something, and hypotenuse is 10. So everything is reasonable here. Okay. I think we got one more from IXL. All right, one more from IXL, and then we'll do a couple from the current review, the review packet at the time of this taping here. So here's one that's a little bit different. I go, there's a square root of 6 in here. Now, I thought square root of 3 was 30, 60, 90. And I thought like square root of 2 was 45, 45, 90. What's the square root of 6 doing in here? That's going to happen sometimes, but same process overall. To get started, I'm going to identify my side lengths, fill into the table. I'll mark the unmarked side length as K just in case we want that. Okay, so there's my sides labeled on the triangle and filled into the table here. And then let's see here if we do. I'll start with K. So we've got the proportion. If I ignore that column, I can say 1 over K equals the square root of 3 over 3 square root of 6. And I'm going to cross multiply and divide here. So 1 times 3 square root of 6. And we're dividing by the square root of 2. All right, so just like we've seen a few times now, we can do this. 1 times 3, that's going to give us 3. And then what happens here, the square root of 6 divided by the square root of 2, I can't remember if we talked about this in another video, but as long as they both have square roots and you're dividing, it's okay to say it's the same as if you did 6 divided by 2 and kept the square root. So that would be the square root of 3, and we're gonna attach that on here. So K would equal 3 square root of 3. And then for our other variable here, let's see, we'll do this one in green. We'll go orange. If I ignore the column with K, I can say, all right, so 2 over Z is equal to square root of 3 over 3 square root of 6. And cross multiply and divide, we got 2 times 3 square root of 6. And we're dividing by the square root of 3. So again, very similar things happening here. 2 times 3, both outside the square root, that's going to be a 6. And then we saw the same thing. Oh, not exactly here. Oops, and I have a typo on the other one. This is square root of 6 divided by square root of 3. I got a 2 in there somehow. And that's going to change things. So if you caught that, good for you. It'll be the square root of 2, not the square root of 3. But same thing there, square root of 6 divided by square root of 3. You can divide the 6 and the 3, you get a 2, but you keep the square root. So that's what we get for Z. Only other thing I'm going to do here is I'm going to check all of these. I'm going to get estimates on the calculator to make sure that the short leg is really the shortest and the hypotenuse is really the longest. Okay, so I did this on the calculator off screen, but K as the short leg is about 4.24 something. The long leg, 3 square root of 6, is 7.34 something. So, okay, so K as the short leg is smaller than the long leg. That checks out. And the hypotenuse Z is over 8, which also checks out because the hypotenuse should be the biggest side. So 8 point whatever is the biggest there. So everything's reasonable. But yeah, that's a little tricky one there. Even tricked me. Let's do a couple from the review, at least the current review packet at the time of this recording. All right, so this is a problem from the review. So we got a 30-degree angle, we got a 90-degree angle. We can figure out that this last angle is going to be 60. But let's go ahead, let's label the sides and let's fill them into the table. Okay, so here I definitely want both of those missing sides, unlike IXL. So maybe I start with W and I can ignore the column with D. And I can say, all right, we've got 1 over W equals 2 over 16 root 3. Cross multiply and divide. 1 times 16 square root of 3 divided by 2. So remember, what's outside the square root can get multiplied or divided. So we've got here 1 times 16 and divided by 2, that's going to be 8. And then the square root of 3 is just going to come along. We're still multiplying by the square root of 3. So that's W right there. That's an exact value. We'll do an estimate in a moment. But otherwise, if I'm thinking about the other missing side length, D, I can ignore the column with W. And we can say, all right, we got 2 over 16 square root of 3 equals square root of 3 over D. And cross multiplying and dividing there, the numbers that are diagonal, we got 16 square root of 3 multiplied by that other square root of 3, and then over 2. So here, as we've mentioned, the 16 and the 2, both outside the square roots, we can divide those, that's 8. And then what happens here, Kind of like in the last problem where we said we had division with the square roots. Well, you can go ahead and just divide the numbers, keep the square root. Same idea here. You could say, let's do the square root of 3 times 3, which is the square root of 9. But some of you know that this is a shortcut. It just go, it's just 3. It winds up just being 3 with no square root. So something we talk about in class usually is to say, if you have the square root of x times the square root of x, it's just x. So square root of 3 times the square root of 3 is just 3. So that comes along here with that 8. So we have the 8, we got the 3 now, and so that's 24 as a value for D. Okay. So the only other thing I'm going to do is I'm going to get calculator estimates for these to say, D is the long leg. That should actually be the medium or the middle side because it should be shorter than the hypotenuse. And W should be shorter. So I'm going to do this on the calculator on off screen here. So, all right, 16 square root of 3 on the calculator is a little over 27, almost 28, which is bigger than the long leg of 24. Hypotenuse should be bigger, so that checks out. And then the short leg, W, 8 square root of 3 on the calculator is 13.8 something, almost 14, but shorter than the long leg. So everything is reasonable in there. Let's do one more from the review, and then we'll wrap this video up. All right, so last problem for this video, I got triangle from the review packet. Again, the review, at least at the time that this video was made. So I'm going to go ahead, I'm going to label the sides, I'm going to fill in the table, and then I'll solve for whichever variable I want to first. Okay, so we got that 60-degree angle that we can figure out. That wasn't given, but we know that's going to be 60. So got my hypotenuse, my short leg, my long leg labeled. Got those variables in the 24 in the table, and so I'll start with I'll start with E. I'll ignore X and I'll start with E. So I have 1 over E equals square root of 3 over 24. Doing my cross multiply and divide. Let's see, the 1 and the 24 are diagonal, so those get multiplied, and then we're dividing by the square root of 3. So let's see, 1 times 24, that's 24 over square root of 3. Now this is where you might remember that, at least myself in particular, I'm picky. A lot of math teachers might be picky and might say we don't like a final answer with that square root on the bottom. So what we're going to do here is we're going to multiply this fraction by 1, because when you multiply by 1, you don't change anything, but it's going to be 1 in disguise. So we're going to make the appearance different, even though we're going to keep the value the same. And if you remember, if you've done the 45, 45, 90 triangles, very similar, that the 1 in disguise is going to be the square root of 3 over the square root of 3. Because what we get to do here now is we get to multiply 24 times square root of 3 in the numerator, and then in that denominator, we got square root of 3 times square root of 3. And if you remember, we just did it, was it the last problem, where square root of 3 times square root of 3 is just 3. Square root of x times square root of x is just x. So now there's no, that was the reason for square root of 3 over square root of 3, that 1 in disguise. It gave us just a 3 on the bottom, just a 3 in the denominator. And now we can go ahead and say, all right, let's take the 24, divide by that 3, but we'll keep the square root of 3 on the top. So 8, oh, sorry, I had a little hiccup recording this. So we did multiplying by 1 in disguise, square root of 3 over square root of 3. We ended up getting 24 square root of 3 over 3, and then that simplifies to just 8 square root of 3. All right, so now we can do the other. So then similarly for x, solve them there. 2 over x equals square root of 3 over 24. We're going to have 2 times 24 over square root of 3, which is going to be 48 over square root of 3. But we're going to do the same thing. If we don't want that denominator with the square root, multiply by 1 in disguise. Square root of 3 over square root of 3. We get 48 square root of 3 over that denominator is just a 3. And then if we divide that, we get 16 square root of 3. So, yeah, so you can check those. They should check out. That hypotenuse should be the longest, short leg E should be the shortest, 24 should be in the middle. But there you go. Hope that helps, and I'll see you in the next video.